You've been training an AI model since the day you were born. Your brain has processed millions of hours of visual data just learning to recognize a coffee mug and figure out which way the handle is pointing. A robot? It starts from absolute zero. This is the robot's eye problem, and it's the biggest bottleneck in humanoid robotics right now. It comes down to two questions that you answer instantly without thinking. What is this thing? And exactly how is it positioned right now? For robots, question one is object recognition. That's identifying that the thing in front of it is a coffee mug, not a soup can. Question two is pose estimation. That's understanding the mug's precise orientation in 6 degrees of freedom, its position in 3D space, plus its rotation around 3 axes. Here's the thing, you do this effortlessly in cluttered rooms, bad lighting, with objects half hidden behind other stuff. A robot falls apart in those conditions. And until they nail this, robots can't reliably grasp, sort, or hand you anything. Tesla's approach with Optimus is fascinating. They're repurposing the neural network architecture from full self-driving. The theory? Visual reasoning learned from millions of miles of driving might transfer to manipulation. Picking up a screwdriver and avoiding a pedestrian feel like fundamentally different problems. But Tesla has surprised people before. But here's where it gets interesting. Not everyone thinks better algorithms are the answer. Some companies believe the problem is upstream, that cameras and conventional sensors simply don't capture enough information to begin with. Aeva is making the most radical bet in this space. Their FMCW LiDAR, that stands for Frequency Modulated Continuous Wave, measures an object's instantaneous velocity at the physics level. No algorithmic guesswork required. It's reading motion directly from the light waves bouncing back. Everyone else is focused on making AI smarter with the data it already gets. Aeva is asking, what if we gave it fundamentally better data? Better inputs might matter more than better algorithms. This is a component-level bet that most people are sleeping on. So who actually has the edge right now? Covariant. And the reason is unsexy but decisive. Data. They're the foundation model maximalists. Their RFM1 model was trained on what they claim is the largest multimodal warehouse dataset in existence. Years of footage from actual commercial deployments, picking millions of different products. While everyone else is running demos, Covariant has been shipping production systems that pick virtually any product on day one. That's not a press release claim, it's backed by actual commercial results. Competitors cannot replicate their training data without similar customer traction. Data moats are real, and covariance is currently the deepest. Now, this is the part nobody talks about. Nobody has cracked zero-shot generalization to truly novel objects in unstructured environments. Current systems still struggle when they encounter something genuinely outside their training distribution. A weird package, an unusual tool, bizarre lighting, the company that solves robust perception for anything without retraining changes the entire economics of robotic deployment. Right now, that's still science fiction dressed up as a roadmap. So why does this matter beyond robots? This is the perceptual layer that all physical AI needs to operate in human spaces. Get this right and you unlock warehouses that run 24/7, surgical systems that can identify tissue, home robots that actually help instead of bumping into furniture. Get it wrong, and robots remain expensive, brittle tools that only work in perfectly controlled environments. The stakes are exactly as high as they sound.